All right. This is the last notebook that we're going to cover for our Python crash course, and it happens to be a very important one. In this one, we're going to specifically talk about time series in Python. And in our machine learning course, there are a couple of projects that has something to do with time series, specifically when it comes to stock valuation. We know that it's a financial time series, so we need to know how to deal with time series in Python in general. Okay, so let's begin time series in Python. All right, so in this section, we're going to learn how to handle time series, and the topics that we're going to cover are basically how to use datetime module. This is a module which is built in Python, and then we can use datetime arrays from Numpy package library, and we can also use datetime from Pandas library. So there are three different ways that we can define an index for a data frame, for example, or we can define dates, right? And I think again, you can use either of them when you're working with the time series data set. But in general, I highly encourage you to learn how to work with pandas datetime. Because again, the data sets that we're going to work with usually come as a data frame, and then pandas itself is a good library to handle the data frame. So why not using pandas datetime itself? Okay. Then we're going to talk about a very cool module in Pandas, which is data reader. And this data reader is going to enable us to literally read the data from online sources from different APIs. So for example, we can read from Yahoo Finance, we can read data from Google Finance, we can read the from a French data sets from their own website, we can read data from Federal Reserve website, and you name it, right? So we don't need to go to their website and download the dataset as a CSV and then import the CSV. We can directly, for example, look at the Apple's stock price using Python and read the data live from Python. Okay. Then finally, we're going to talk about what is resampling, time shifting. Basically, we talk about leads and lags. And then finally, using rolling windows and expanding windows if you want to do moving averages in time series, for example. All right, so let's start with again, there are three different ways: datetime module, NumPy, and Pandas. So let's start with datetime. So we're going to say from datetime, import datetime. Again, this is a convention, right? So you can import it as anything, DT, but just stick to the convention. People use datetime. So from datetime, we're going to import datetime. Now, let's say, let me split this actually. Now, let me split from this. Oops, what did I do? Nope. Yeah. Okay. Let's say year is 2021, month is 1, day is 1, right? So I just save them somewhere as a year, month, and day. And I'm going to define my date. Now, if I type date time, it's waiting for 3 when you open the contextual help. It's going to wait for arguments, right? So the arguments are going to year, month, day, and you can also add hours, minutes, seconds, and even microseconds, right? But we know that usually we're going to use year, month, and day, and sometimes maybe hours, but not for minutes, depending on the context. But in this course, we're going to at most we go to a day granular data sets, not less than that. Okay. So say, okay, date time, again, year is year, 2021, month is 1 in January, and day is 1. So if I want to look at my date, so my date is going to be a date time, and it's 2021, 1 hours and minutes, right? 00. We can extract any information from that date time object. So I can say my date, give me back the month. Well, actually, if I go ahead and say my date dot tab, then these are the things that we can extract from. For example, date, day, and different functions, max, mean. So for example, if you have an array, it will tell me what is the max, things like that. Okay. All right. Then again, for example, one function that we can use is called the is weekday, right? Well, basically, which weekdays it is. So if you look at the documentation for this function, it says Monday is 1, Sunday is 7, right? So for example, if I say, when I pass this date, my date, and ask for the number of the day, weekday is going to return 5. And I know 5 means Friday. So the 1st of January happens to be Friday. Okay, so that was one way to define datetime variables in Python. The second one is NumPy. So we're done with the datetime module. Now let's look at the NumPy arrays, datetime arrays. So as we said in the Python basics notebook, NumPy handles dates more efficiently than Python datetime format. So we already know that NumPy is going to be more efficient with datetime. So already we know that this is the better version. And then later on, we're going to say that, you know what, this pandas datetime is going to be the best. And throughout the course, I believe we're going to use a combination of these two methods. Okay. Let's import our NumPy as NP, and then look at that. We're going to create a datetime array. So NumPy array, so far we're completely familiar with NumPy, so I know if I can generate a NumPy array, and I can pass 2020, the 20th of January and 20th of January 2020, 2021, right? And date type, I think we have seen this before once. Now this is the right time. Datetime 64 is basically datetime reserved for Python. The reason the NumPy is using, for NumPy, sorry, NumPy is using 64 because it's want to distinguish its datetime from the datetime module. Okay, datetime module, the type is going to be datetime. Now here, NumPy, in order to separate itself from the default datetime method in Python, it said, okay, the object is going to be, the type is going to be datetime 64. And as you can see, there is a little d here. It basically says that the type is date. We can change this date to year, to hours, to month, and etc. Right? So if I look at this NumPy array, as you can see, these are two dates. I can change it to, I can save them as years, right? Now I can change it to years. As you can see, the return is going to be 2020, 2021. I can do month and etc. Right? Let me see if there's any documentation here. If not, you can Google them online. I think I provided one link. We'll see it later on. We're going to talk about these D, Y, and etc. All right. Now, we can also use this NumPy arrange. Remember, we could use an arrange. And you see how useful is that? So for example, I say, give me from 1st of January 2021 to 10th of January 2021. And give me by day, right? So if I do that, it's going to basically generate these 10 days. Actually 9 days. 1, 2, 3, 4, 5, 6, 7, 8, 9. So up to 10th of January. So this is how we could use basically NumPy array date times in Python. Okay. Now let's move on to the one that we're going to use extensively for the course, which is Pandas datetime. Usually we will work with time series as datetime index. So let's see how we can handle those things. All right. So let's import Pandas as PD. And now let's create an index first. So we want to, at the end of the day, I have a data frame. It has a maybe it has different columns. And one column, we're going to call it index column. And in that index column, we want to save our dates, right? So let's generate that index column manually. Usually we don't need to do it manually. The data sets that we download, they come with a time, date time column, and then we're going to use that as an index. But imagine you don't have that column, you want to generate it manually. So I'm going to say that pd.dateRange, so give me a range of date from the 1st of January 2020, give me 7 period, whatever the period is defined, whatever you define the frequency. So frequency is days, so give me 7 days of data and save it as an index. Now show me the index. So 1st of January, 2nd, 3rd, up to 7th, right? Because we did specifically told that, okay, give me 7 days. If I change it to 20, of course, I will give it 20 days, and etc., right? And if you pay attention, the type of Pandas datetime is going to be datetime 64. This is very the same as, do you remember NumPy arrays? Datetime 64. So as you can guess, as we said in the very first, I think, video, that Pandas is built based on NumPy. So we can see it here. All right, here's a list of frequency parameters. This is the link that I was talking about. Now, so this, for example, B stands for business days, C custom business days frequency, D calendar day, W weekly, monthly, These are business month, frequency, and you name it. There are different ways, right? So, for example, I don't know, milliseconds, nanoseconds, and etc. Right? Let's go back here. Okay, now, for example, you want to create an index for a specific day. Basically, you want to create a custom index, right? So I want to see there are two specific days, right? So I'm going to say, I call it custom index, and I do PD. I'm not going to use dates range anymore because I want to specifically uh, talk about two dates, two specific dates, right? I say, okay, PD dot to date time. Basically, it's going to take a value and return it to a Python datetime object, right? So what are the values? It's a list of two numbers, maybe the 6th of January and 21st of January. Maybe for some reason you're interested in these two dates, right? Let's look at the custom index. So our custom index is going to be the 6th of January and 21st of January, right? And so, for example, we can have another custom index. Well, alternatively, instead of doing this to date time, we could have used datetime index methods. Again, for one specific task in Python, sometimes there are a dozen different ways to come up with that. Don't be confused or don't be overwhelmed. This is actually, it's a good news. There are many different ways that you can get the same answer. So why not learn at least one or two of them or use them alternatively, right? So alternatively, we can define this custom index using datetime index, and we can pass a NumPy array and basically do something like this. Okay. I personally prefer to remember to datetime because this is very powerful. There are different arguments that I can use, and then so this is from Pandas library, right? To datetime and then pass a list. Automatically, it's going to transfer all of them to a NumPy array datetime. Okay. Now let's say our custom index is, let's say, 1st of January and 19th of January, right? Now let's explore some of the Pandas, the datetime function. I'm going to make a data frame. Remember, we know how to make a data frame. We do pd.dataFrame, capital D and capital F. So first, I have to pass the data. The data is going to, I just want to call it first day of the year, first day of the school. The index is, let's say it is my custom index, 2 days. And column names, I can give it a name. I can call it events. Now let's look at the data set. So this is my data set, right? Basically, the events, first day of the year, 1st of January, first day of school, 19th of January, and etc. So this is how you, if you want to do a custom time series data frame. But as I said earlier, we rarely do that because all the data sets that we're going to work with already come with a time index. So out of this data frame, I can say, okay, what are the name of the columns? There's only one column, events. What is the index? Index is going to be date time. I already know that this is my index. The 1st of January and 19th of January, and the type is NumPy array, date time. I can say df index max. So what is the max of that index? So we know that between 1st of January and 19th of January, the max is 19th. And again, this is hours, minutes, and seconds. And I can say, what is the argmax? So what is the what is the location of that max? Location is between 0, 1, so it's 1, right? So it's, usually it's this argmax, sometimes it's useful, but you want to see what is the last day of your data set. Or for example, yeah, you can see what is the last day by doing something like this, what is the location by doing something like this. So for example, if this number was 1000, I know that my time frame has one length of 1000. Of course, there are a dozen different ways to come up with the size of the data frame, right? Okay, so far, basically what I covered was just some basics of the date time, right? So we don't do any of these things manually. So from this part that I'm going to introduce you to Panda Data Reader, we're going to import data sets that come with a datetime index themselves. So let's see what is Pandas Data Reader. We have to import that. So we're going to import pandas data reader data as web. The convention, some people import it as data. So I have seen people import it as either data or web. But I think web is more informative. Basically, it suggests that you're importing something from websites, from online, so or from some different APIs. So I'm going to use web. But if you saw some people use data, don't be surprised. This is one of those things that there is no consensus. But I'm going to stick to the web. Okay. Now, if I do web dots, see how powerful is that? We can, well, actually, we have to do data reader, but basically, these are the things that we can do with that. So it comes with different classes. We haven't talked about class, but we know what is function. Class is basically a combination of multiple functions. And then, so for example, we can do from a French reader, Eurostar reader, Fed reader, reading stuff from Federal Reserve. We can get components from Yahoo. We can, I think, get data from French, Fred, Google, Quandle. This is for algorithmic trading. Robinhood, this is literally the broker Robinhood. And again, you see how powerful is that? So we can get different codes from NASDAQ and things like that using this data reader, right? We're going to play around with that. So let's say this start, we need to define a start and an end if you want to use the data reader. So a start is going to be, I'm going to use it, I'm going to define a date time. So this is my start date, the 1st of January 2020. And the last day is going to, if I say today, it's going to give me what is today, right? So basically, let me actually, yeah, if I ask what is end, it's going to give me the date of today, which is 19. So it's, yeah, it's basically 10:20 at the 19th of January that I'm making this video. Okay. All right. Now I'm going to say, okay, for example, I have a ticker, object ticker, and I want to put two stocks in it, Tesla and Apple. You can go ahead and put space and then do MSFT, I don't know, maybe Qualcomm, whatever, maybe Facebook. And now if you use a split, your ticker is going to be a combination of all these stocks, right? But here, for the sake of argument, because I want to make sure that everything is going to happen fast, real time, I'm going to stick to two stocks, maybe Tesla and Apple. Okay, so far so good. We have a start, we have end, we have the list of tickers. Okay, now I'm going to say, go ahead, use this web. You remember this is where we can grab data from, for example, Yahoo. Out of this web, let's call the method data reader. Okay, so this is my data reader. So data reader is looking for name. So name is going to be our ticker. So maybe Tesla, Apple. Then data source. The second argument is data source, which is Yahoo. So again, it comes as a sequence, but if you want to make sure that you understand what is each of them. So I can say name, I can say the second one is data source, then start is a start, and is end, right? And so if I run this line, it's going to go to Yahoo Finance dataset and then look for Tesla and Apple stock. And I'm going to ask you to show me the details, right? Let's look at that. So this one is going to take a while. So for example, because if I wanted to only look at maybe only a year of data, yeah, roughly a year of data, a year and a month or something like that. And then maybe 230 observation, daily observation. And then only two stocks, that was fast. But if I pass, let's say 500 or 100 stocks, and I want it for 10 years of daily data, this is going to take a while, depending on your internet speed connection, speed and things like that. Okay. So if I look at the tails, this is a data frame. Let me actually minimize this one. So basically says that by default, it shows you high, low, open, close, volume, and adjusted close, right? So for example, the adjusted close for Tesla, today, I look at the tail of the data set, right? It was 844. For Apple, it was 127, right? So this is, as you can see, how easily we can grab data using this Pandas data reader. Okay, and now imagine you're only interested in this adjusted close. So I'm going to grab only the adjusted close column, right? And I'm going to round these numbers up to 2 decimals and save it as my data frame, right? So now if I look at the tail of my data frame, look at that. The index is already date, which is awesome, right? So the index is already date, and then I have Apple adjusted close, Tesla adjusted close. Now I can play around with this data frame. I can say, okay, now let's say for now, let me again split this To import matplotlib.pyplot as PLT, I'm going to use the matplotlib functions, right? So for example, here I'm not going to use Seaborn, but I could have used Seaborn as well. But again, as I told you guys, I'm going to use matplotlib, pandas visualization, and Seaborn interchangeably. I will use the one which I believe is best for that specific purpose. But again, nothing should stop you to explore other visualization packages. If I want to plot, actually, this is pandas visualization dot plot off of a data frame. So data frame Tesla plot, show me the color is going to be red, and then show me the plot. So this is a plot of Tesla from 1st of January 2020 up until today. Okay, we know that it started. So this is post the split, right? So literally going from 100 to 840 something, eightfold it got. Uh, Eightfold within a year, which is insane, right? Okay, so this is how you can plot Tesla. And if you want to see what are your indices, so index starts from the second, well, the 1st of January was holiday. So 2nd of January, the market was open up until today, which the market was open, right? At 19th of January, 2021. There are 260-day observations. The frequency is date, of course. Okay, so this is how we can plot these things, right? Now we're gonna see how we can plot Apple and Tesla together, and then how we can make a legend and things like that later on. But let's move on to the next topic, which is resampling. This is very powerful. And what do we mean by resampling? Imagine I have a daily data like this. Remember, my data frame is a daily data. I want to say from this daily data, look at the intervals of monthly and take the average. So take me, for example, give me the average close price of Tesla in January, February, March, and etc. And do the same for Apple, right? So this is what we call resampling. Okay. So resampling data by different rules or different frequency. Here's a list of frequencies. So let's look at the list of frequencies, how we can basically collect those things. So this is something that we have seen before. So we can say that, okay, summarize the data, the daily data based on weekly frequency, summarize the daily data based on monthly frequency, right? So let's have some fun with that. I'm gonna say, actually, let me do this step by step. If I do df resample, open close brand, of course, we can look at the contextual help. Basically, the first thing is asking you is, what is your rule? So your data is daily, right? This is the daily data. What is your rule? I want to say do something based on monthly aggregation. Does that make sense? Monthly aggregation. So the rule is month. So I know for month, I use capital M. What do you want to do with that? Take the average. Okay. So this is how you should read it. Take the data frame, resample data set by monthly rules. Out of that, give me the average. So if I run this line, so what's the output? So the average price for Tesla in month of January 2020 was 105. The average price for Tesla in December 2020 was 638. Okay. And for Apple, the same story, 77, 127. And by the way, these are post-split numbers. Both Apple and Tesla got a stock split in 2020. So these are post-split numbers. So that's why it is adjusted close, adjusted for dividends and split and etc. All right. So then what's the point of that? We can plot them. We can plot them, and then we can compare, for example, the averages and things like that. Now let's do a cool exercise. Imagine we want to resample based on a custom resampling, not necessarily monthly or weekly or things like that, right? And for example, I want to plot the normalized monthly average prices. So what do I mean by that? What is normalized? So remember, if I want to plot, let's actually do that, and you will see what's the motivation. If I just erase Tesla, I plot this one, it's not a good idea to look at Tesla and Apple on the same graph. Well, you can do that, but one of them was literally exploded to eightfold. The other one, maybe 70%, 80%. Then maybe you want to say that let's normalize these things, right? So let's divide everything but its initial price. So they both start from 1 and see how many times they got bigger, right? So here, for example, Apple started from 128, Tesla, well, no, not 128. I have to look at the head. So Apple, let's look at the head. So Apple started from 74, Tesla started from 86, right? I want to normalize this thing. I want to say that, okay, divide Apple by that 74 and Tesla by 86. So that's why what I mean by normalizing. Let's actually leave it like this. This is fun. Okay. So how we do that? I'm going to say df. Actually, let me do it. Let me do it separately. Df resample. What is your rule? The rule is going to be monthly. And we can say in the monthly, apply the averages, right? So far, this is the same as what we saw before, right? Now, I want to add, basically, I want to add something to that. I want to add, give me a second. Okay. I want to basically to plot the normalized monthly average price, right? The normalized, right? So basically, I say that, okay, out of these things that you see here, go ahead and divide everything by the first element. So divide Apple by 77.3, divide Tesla by 105.7, right? If I want to do that, now I can apply that Lambda function because this is a custom function that I want to use it once. So I use that anonymous Lambda function. I say, okay, Lambda, and then, so what do you want to do? For example, X or Y or whatever. So let's do Y. And take that number divided by the first elements in that range, right? So Y is going, so basically it's going to say that in this column, take each row and divide it by the first element in that row. So here it's going to be 105. If you take the first two rows, the first element is going to be 105. First three rows, 105. And so it's going to go ahead and take this number and divide it by the first number. This number divided by first number. This number itself divided by itself. So it's one point something, 1 point something, and etc. Right? So this is what we call normalized monthly average. Okay, so this, if I run this line, basically now Tesla and Apple are one, so I can compare apples to apples now, right? Well, it's an irony, Apple, apples to apples. Well, it's apples to Tesla. And so now this is more informative, right? Because it says that the monthly averages in Apple goes from 1 to 1.6, literally 70% increase. But for Tesla, go from 1 to 769, well, 7.69, basically almost 800% increase, right? So now off of this one, let me actually leave it like this because you see what's going on. And off of this one, I can do plots. So let's do plot. I can change the figure size at the same time. And let's do that. So this is, now it's more informative. Both of them start from 1. I can see. And automatically it's going to add the legend. All right. So let's look at another example. Imagine we want to draw a bar plot now, and then comparing monthly returns between Tesla and Apple. Okay, so again, monthly returns. So that's why we do resample, and then we're going to apply a Lambda function. So these are monthly returns. It's basically, if I want to do monthly return, it says that take the last element divided by the first element within a month and subtract it from 1. So this is growth, right? So end of the month divided by beginning of the month minus 1. If I change it to W, it's going to be weekly. End of the week, beginning of the week, minus 1. So that's growth, right? So here we're going to do M. So basically, Tesla, in January, the growth was 0.5. Apple, it was 3%. So 50%, is it? Yeah, 3%, 50%. Yeah, that's literally percent. Yeah, yeah. The Tesla in the month of January 2020, it grows to 50%. Well, the numbers are not lying, so I think it is. And then it dropped 14%, 29% consecutively. Yeah, so this is COVID, right? Yeah, this is correct. So in COVID, in February and March, we had 14% and 30% drop consecutively. I think Tesla went back to 350 pre-split, and then it skyrocketed afterward, 60%, 19%, 20%, 27%, etc. Okay, so this is the data. Now, if I want to simply do bar plots, I do dots, plots dot bar. I think bar plot also works. Well, anyways, we know that plots dot bar is going to work, or I can do plots. Then here I can say kind is equal to bar, right? So both of them is going to work. But let me keep this here because you see what's going on. And then I'm going to do plots dot bar and change the fixed size. So here is the average monthly return comparison between Apple and Tesla, right? During the COVID, Tesla dropped a lot more than Apple. And after that, Tesla outperformed the entire market, not only Apple, insanely, right? So an increase, and then we had a pullback in September and October, and then after that, even now, the first month of 2021, Tesla is doing crazy, right? So far, the average is 15%. Okay. So that was resampling. Then the last thing, no, it's not the last thing. The next one is time shifting. So time shifting, basically, we're talking about leads versus lags, right? So let's make a data frame, call it df apple. And basically, we're only focusing on the apple. And then, actually, let me separate these things. Then look at the df apple. So basically, we're extracting only the first column from our previous data frame, right? Just apple, right? Now I'm going to add the lags and leads. I'm going to make a new column, call it lag. So lag means t-1, and another new column, lead, t+1. Then I have to say, okay, what column you want to make changes? So I say df apple, column is apple, right? Well, frankly speaking, I didn't need to generate a new data frame called df apple. I could have worked with df, but anyways, I want to show you only maybe for one of them, it's easier to understand. So if I do dot shift 1, so when I do dot shift 1, it's going to shift the entire data set one row forward, shift +1, right? And if I do shift -1, it's going to pull it back one observation backward, right? So that's why we call it lag, we call it lead. Now, if I look at the head of this new data frame, so I have Apple, 74, 73, 74.3, 73.9, whatever. The lag, so let's say today is January the 3rd. So what is the price for the yesterday? 74, right? So this is 74. So this is what we call lag. So let's say today is January the 7th. What is the lag price? 74.31. What is the lead price? 70. Well, you have to say one thing afterward, right? So it's basically to push it down. So for example, you say we shifted to one upward. So let's say today's price is 73.72. So yesterday, it's as if we know that the price of tomorrow is going to be this. So that's why we call it lead, right? All right. Okay, now finally, let's talk about rolling windows and expanding windows. So let's construct a 30-day simple moving average, right? So let me remind you what was our data frame. So if df.head, so in our data frame, so that's why, in our data frame, we had Apple and Tesla, right? I want to use a rolling window, okay? And let me actually tell you what is rolling window. So rolling window means that take the 30, whatever frequency is. For example, the rolling window 5 means that take each 5 days and move forward, right? Roll it forward. So and what do you want to do with that? You can take the average. Take the average of the first here 30 days and show me the head of them. Take the average of the first, let me actually play around with that. Let's do 1. If I do 1, you see there is no difference between these two the outputs. Data frame, Apple is 74.44, second day 73.72, and etc. Because the rolling window is 1. Each day, we're going to take the average. So the average of one day is the same number and show you the data set, right? If I change it to 2, what do you think is going to happen? Pause the video and think about it. Okay, so the first row is going to be NA, right? Because it says that. So what is the average of this one and the previous day? There is no previous day. But for the second row, it's going to be the average of 74.44 and 73.72. If you take the average, you will see that it's going to be 74.08. For Tesla, same story, 87 point something, right? So this is a rolling window of 2. If I do 3, not surprisingly, the first 2 days are going to be NAs, right? Now, what is the third observation? The average of the 3. If I do rolling 5, all of them are NA, and this 74.31 is the average of these 5 observations, right? Now, we're going to see the rolling average of the first 30 days, right? So not surprisingly, all of the first 30 observations are going to be NA. So if I look at the tail, so I get some numbers, right? So this is the tail, right? Or yeah, let's look at the head. Let's actually stick to the 5 that you can visualize. And then let's first visualize the 5, and then we'll move on, okay? We want to plot basically the moving average, right? So I'm going to say, let's define a new column. That new column, let's call it MA5. This is moving average 5. And I can define it as, closing price of Tesla, rolling, what's the window, 5. What do you want to do with that? I want to take the average. You can take the average, you can take the standard deviation, you call it rolling standard deviation. Instead of moving average, call it moving standard deviation. Whatever function that you can think of, right? Median, mode, and things like that. 5. So now in my data frame, let me actually split it and show it to you. Okay, if I look at the head of the data set. So what do I have? I have Apple, Tesla, and moving average. Well, we want to talk about the moving average of Tesla. So this is maybe to be complete, I should call it Tesla moving average. Tesla A5, right? So this is better. It's going to add to this thing here because, so let me, yeah. Oh, we're going to fix it. And so this is the rolling average of the moving average for Tesla closing price, right? So this is repetitive. We don't need that. Well, actually, we can go ahead and delete that one. Yeah. What do I want to delete? MA5. So now if I look at the head of the data set already, it's going to be just fine. Okay, so we have Tesla and a moving average of 5 days of Tesla, right? Now, if I simply use the plot function out of this, I want to see what is the plot of Tesla, and we just renamed it to Tesla underscore MA5. And yeah, and then we want to look at the plot. See, the output is going to be 5 days moving average of Tesla. So I have Tesla, and it's 5-day moving average. And as you see, if I increase the plot size to, let's say, 16, the first 4 days, there is no observation for moving average because it needs the first 5 days to take the average and report it here, okay? Now, if I increase this rolling window, I'm going to smooth out the moving average, right? So if I want to smooth out the moving average, let's call it 30. This is going to be 30 as well. So now I have 5 and 30. Again, we need to go ahead and drop this one. But anyways, this is the, well, actually, we can plot all of them. Why not? This is fun now that I have all of them. So Tesla, the average 30. Okay. Now we see we have Tesla moving average 5 and moving average 30, right? Not surprisingly, the 30 moving average is going to start from day 30, right? So we don't have information here. And it's going to be a lot more smoothed out, right? And so we can think of them as trading strategy. For example, fast moving average, slow moving average. When they cross from above, it's a sell signal. Then from below, it's a buy signal, and things like that. So it says that like a sell here, buy here, maybe buy here again, maybe sell, sell, buy, and then buy here, and then you're good. Again, this is for algorithm trading, but basically this is a good example for time series. All right, so that was the rolling average. Sorry, moving average using rolling windows. We can calculate the same stuff using expanding windows. So what is expanding windows? Basically, expanding says that, okay, if you're using expanding, the windows are simply being added up to each other. We are not going to roll them over, for example, for every 5 periods, right? We are going to expand them from day 1 to the last day. Okay. So let's actually visually see what is that. So for example, I'm going to work with Apple data set, and then I use expanding, I use the average, and look at the head. Okay. So basically, let me actually, before doing that, let's look at Apple itself. Apple. Let's look at the. So this is Apple itself, right? The 2nd of January, 74.44, 73.72, and etc. Right? When I do expanding, the output is going to, so the expanding of, and I'm going to take the average, right? 1 day, 74.44. Second number is the average of the 2 numbers. Third number is the average of the 3 numbers. Fourth number, the average of the 4th number, and etc. And it's going to expand to the end of the data set. So if I look at the tail of it, so the last number, so if I look at the tail of these things, this 9.96.47, this is the average of the entire data set. Okay, does that make sense? All right, so usually we don't, at least for trading purposes, we're not going to use expanding windows because there are some structural changes that happens in the market, right? So for example, Apple today is different than Apple 10 years ago. So when you're working with data, why you need to include information from 10 years ago in the stock price? Again, if you're doing day trading and things like that. If you do not agree with this statement, you can use expanding window, right? And so for example, I'm going to make a new column, call it expanding average. So this is exactly what we defined. And I'm going to plot Apple versus expanding average and show it here. So this is basically Apple using expanding average. And again, in my opinion, there is zero value added in terms of trading signal, because expanding windows, so it basically says that the average for the entire, so what is this number? This last number, I think it was around 96. That's the average for the entire data set. So what does it tell you? What is the average price for the entire history of Tesla? I don't know what it is, but we can calculate that number. But what does that tell you? Is it overpriced here, underpriced here? So again, I just wanted to show you that this, we're gonna, actually we don't use it in this course, but sometimes using expanding windows makes sense, but most of the time when it comes to trading, we're going to use rolling windows. When it comes to cross-validation, we're going to use rolling windows and etc. All right, that was time series, and it's very, very exciting field in finance, financial time series. And Python is super powerful when it comes to visualization of time series. And R is even more powerful when it comes to time series, to be fair. But in this course, we're going to use Python for the machine learning. And yeah, I love both of them. I love both Python and R. And there is no, to me, it's both of them are good, so I don't complain. All right, so I hope you enjoyed this crash course tutorial in general. And again, one last comment is that it's a lot, right? So I think we ended up having this crash course is 4.5 hours. I want you to go over this 4.5 hours multiple times during the semester, not today, not tomorrow, not this week. Just at least go over the Jupyter Notebook once and then try to practice these things again and again and again. Don't be harsh on yourself. This is completely new language. Maybe for some of you guys who are not familiar with Python, and there's a chance that you take a complete 3-credit course in Python and it doesn't cover as much as we did in this crash course. So I totally get that. This was a lot, but this is the basics of what we need for our machine learning course. Okay, good luck until I see you in person. Practice, practice, practice.